Imagine standing on the shores of the English Channel. Out of the fog emerges a giant machine, unlike a ship, train, or airplane. It loads dozens of cars and hundreds of passengers before racing toward the horizon. These incredible vehicles crossed the English Channel faster than many ferries, carried millions of passengers, and traveled where conventional transportation simply couldn't. For a time, they seemed destined to become the future of transport. But then something strange happened. The technology didn't suffer a catastrophic failure. It wasn't banned. It wasn't replaced by some revolutionary new invention. It simply began to disappear. Today, most people have never seen one in person, despite the fact that they were once considered the next great leap in transportation. So what went wrong? How did a technology that looked like a clear winner become one of engineering history's most famous dead ends? Let's find out. Most people think hovercraft are small rescue boats or tourist vehicles operating on ice and marshland. The reality was far more impressive. British engineers built enormous passenger hovercraft capable of carrying entire fleets of vehicles. One of the largest measured nearly 60 meters in length and weighed roughly 300 tons. This floating giant could carry 60 cars and more than 400 passengers at the same time. Many people found it difficult to believe that something so massive could literally lift itself above the water. Despite common myths, these hovercraft were not slow or unreliable. They traveled across the English Channel at speeds exceeding 110 kilometers per hour. While conventional ferries required up to 3 hours to complete the crossing, hovercraft could make the journey in approximately 30 minutes. Imagine a 5-story building filled with cars and people racing across the sea at highway speeds. That was everyday reality. At their peak, these vessels transported millions of passengers annually and generated enormous profits. It seemed inevitable that hovercraft would dominate maritime transportation.
To understand hovercraft, we need to look underneath them. Many people believe a hovercraft is simply a boat with a giant fan attached to the back. That's not how it works. A hovercraft operates using controlled air pressure. Instead of floating directly on the water, it rides on a cushion of compressed air. Powerful gas turbine engines drive enormous propellers, while separate lift fans force huge volumes of air beneath the vessel. Around the perimeter sits a flexible rubber structure known as a skirt. This skirt traps the air underneath the craft. As pressure builds, the cushion becomes powerful enough to lift hundreds of tons into the air. The vessel rises approximately 2 meters above the surface. Only a tiny gap remains between the skirt and the water. Excess air escapes through this gap while continually supporting the craft's weight. Because the hull no longer touches the water, drag is dramatically reduced. This is what allowed hovercraft to reach such remarkable speeds.
Hovercraft looked futuristic. Traveling inside them was a different story. Unlike traditional ships, they didn't cut through waves. Instead, they skimmed over them. Passengers expected a smooth, floating sensation. What they experienced was something closer to sitting inside a giant aircraft engine. The noise was overwhelming. 4 massive turbine engines produced such a deafening roar that passengers often had to shout just to communicate. The cabin vibrated constantly. Every wave transmitted shocks through the vessel's structure. Many passengers became seasick within minutes. To make matters worse, the powerful airflow generated enormous clouds of spray and salt mist. Windows quickly became covered with water, making it almost impossible to see outside. People tolerated these uncomfortable conditions for one reason: speed. A 30-minute crossing was worth enduring a noisy and rough ride, at least for a while. Controlling a hovercraft was unlike steering a normal ship. Traditional rudders rely on water flow. Hovercraft had almost no components touching the water. As a result, pilots controlled them more like aircraft than ships. Large propellers could be redirected to change thrust direction, while massive control surfaces at the rear helped steer the vessel. The challenge came from momentum. Even after initiating a turn, the craft continued sliding forward. At high speeds, a hovercraft could drift hundreds of meters sideways. Pilots constantly fought to maintain control and balance. Operating one of these giants required specialized training and skill. Many people believe hovercraft disappeared because the Channel Tunnel opened in 1994. That's only part of the story. The real problem arrived much earlier: fuel. Hovercraft depended on enormous gas turbine engines. These engines consumed astonishing amounts of aviation fuel. During the 1960s, fuel was relatively cheap. Operating costs remained manageable. Then came the global oil crises of the 1970s. Fuel prices exploded. Almost overnight, hovercraft became dramatically more expensive to operate. A conventional ferry could carry far more vehicles while burning inexpensive marine fuel. Hovercraft carried fewer vehicles and consumed vast amounts of costly aviation kerosene. In some cases, transporting a passenger by hovercraft became more expensive than flying them on an actual airplane. The economics simply stopped making sense. Fuel wasn't the only expense. The hovercraft's rubber skirt became another major problem. Traveling at over 100 kilometers per hour meant constant punishment from waves, sand, rocks, and salt water. The skirt wore out rapidly. Damage occurred constantly. Repairs were expensive and frequent. Replacing large sections of skirt material could cost enormous sums of money. What had once seemed like revolutionary transportation was becoming a financial nightmare. Operators raised ticket prices to compensate. Passengers responded by returning to slower but cheaper ferries. Routes became less profitable. Companies began shutting them down. While commercial operators struggled with costs, military planners saw things differently. For the military, speed mattered more than fuel efficiency. Soviet engineers developed one of the largest military hovercraft ever built. Its name was the Zubr. At approximately 57 meters long and weighing around 550 tons, it dwarfed most other hovercraft. 5 powerful engines generated roughly 50,000 horsepower. The craft could transport armored vehicles, troops, and military equipment directly onto beaches. Unlike traditional landing ships, it didn't need deep water. It could travel over sandbanks, shallow coastal areas, and even minefields. At speeds exceeding 130 kilometers per hour, it could deliver soldiers and vehicles directly onto shore. It was an extraordinary military machine. Despite their impressive capabilities, military hovercraft suffered from the same weaknesses as civilian models. They were expensive. Maintenance was complicated. Salt water damaged sensitive systems. The enormous rubber skirts required constant repair. After the collapse of the Soviet Union, maintaining these fleets became increasingly difficult. Many vessels were retired, placed in storage, or scrapped. Only a handful remain in service today. Hovercraft are often remembered as a failed technology. That's not entirely accurate. The technology worked remarkably well. It accomplished exactly what engineers designed it to do. The real problem was economics. Hovercraft demanded the maintenance of a military aircraft while being expected to earn profits like an ordinary ferry. That imbalance proved impossible to sustain. In many ways, hovercraft were simply ahead of their time. Today, the giant passenger hovercraft that once crossed the English Channel are gone. A few surviving examples sit quietly in museums. One was dismantled and scrapped. Others survive as historical exhibits. They stand as monuments to an era when people genuinely believed the future of transportation would glide above the water. Smaller hovercraft still exist today. Rescue teams, geologists, military units, and remote communities continue to use them in environments where traditional vehicles cannot operate. Frozen rivers, swamps, marshes, and shallow coastal regions remain perfect territory for hovercraft. But the age of giant passenger hovercraft carrying hundreds of people and dozens of cars is over. Hovercraft proved that engineers could make a 300-ton machine fly above water at incredible speeds. Yet, technology alone wasn't enough. Economics ultimately defeated engineering ambition. The world chose slower, cheaper, and more efficient ferries. And so, one of the most fascinating transportation experiments in history quietly became a relic of the past. If you enjoy exploring forgotten technologies and ambitious engineering projects, be sure to subscribe and join us for the next journey into history.